So for today, we're talking about characteristics of a higher degree polynomial function. All right, so this is a polynomial. Do you guys know what poly means? Many or multiple, yes. But weirdly, a polynomial can have just one term if you want. Okay, so even y equals 5, that's a polynomial. That seems kind of lame. Seems like there should be at least two to be a polynomial, but the fact is you can be just y equals 5. What if I make it 5x? Is it still a polynomial? Yep. What if I make it 5x plus 3? Then it's still a polynomial. What if I make it 5x to the 5th? It's still a polynomial. What if I make it 5x to the negative 5th? Not a polynomial anymore. You can't have weird powers in polynomials. Can't have weird powers. What's a weird power? Like a fraction power? That's weird. Can't have those. And you can't have negative powers. This would not be a polynomial. So polynomials, it's all about the powers. If the powers aren't weird, like negatives or fraction powers, then you're fine. All right, so is this a polynomial? Yes. Yes, it is, because it doesn't have weird powers. All right, next thing you're supposed to know about them is that's called the lead something. And that's not the lead coefficient. That's the lead term. Do you get that this thing had 3 terms? That front one, that was the lead term. Now, just to clarify, if this had been like to the 20th power, even though it's not in front, then this would have been the lead term because it has the biggest degree. I think of it a little bit like generals. Have you heard of a 1-star, 2-star, 3-star general? Okay, and the highest it goes is 5-star, and then usually that's like the joint chief, chairman of the Joint Chiefs or whatever, like a super high level military person. Okay, so if the higher this is, the bigger it is, they're in charge. Okay, so in this scenario where I just changed this to a 20, then that would be the lead term, even if it's in the middle.
So the biggest power is the lead term.
The biggest power tells you that's the lead term, yes, even if it's not in front. Now, just to clarify, you're supposed to put the biggest power in front, but we're math teachers and we like to mix it up and test if do you really understand. So sometimes we'll put the 8 in front and say 5x to the 3rd here and then plus x, and then we'd say what's the lead term, and you're supposed to know it's that one because it's got the biggest degree. All right, does it still have 3 terms? Yeah, 1, 2, 3 terms. But that's the biggest degree. So really it should be first, so I should really move the 8 to the end. It's almost like a math problem where it isn't done, but if you rearrange it, you should know that's the lead term. And the lead coefficient is that. A coefficient is the number in front of the x. All right, so that 5 is the lead coefficient. The 5x to the 3rd, that's the lead term. Now, if I put a y equals in front of this whole thing, which I did, remember y is the same as f of x, right? So this is a function that is a polynomial. It has 3 terms. Its lead term is 5x to the 3rd. Its lead coefficient is a 5. Oh, and its constant is an 8. Do all of those things I just said make sense to you? A lot of terms there. Constant, coefficient, lead term, lead coefficient. Yes?
Does the lead coefficient have to have a variable?
Excellent question. If it was just, it doesn't have a variable, let's say it was just 8. It's still a polynomial, but it's not a coefficient because it's only called a coefficient if it's on an x. Know what I mean? Yeah. So if it doesn't have that, that's not a coefficient anymore, it's called a constant.
Okay, so 8 was like...
8 is the lead term. And even if it's to the 20th, 8 to the 20th is just a really big number. Okay, so even if I put like 8 to the 20th, it's still just, it is the lead term, but it's not a coefficient because it doesn't, there's no x. This is just a really, really big constant.
Yeah, but if it was in like the other, the 2 term one.
Okay, so if I move the 8 here to the front, do you remember that wasn't the lead term even though it was in the front? Because there was something that had a bigger power than it. So it's just the constant, we can move it to the end.
Yeah, but if 8 has a bigger power.
But it doesn't. But if it had a number, if 8 was to the 5th, it's just a big number.
Okay.
I know this has a 3 and that has a 5, but they're different because 8 to the 5th is just a number. It actually should be simplified then and made into something like, 5,476,000 or whatever. So this one would still be a constant even if you put it to a power. All right, so back to this. We get this question and all of a sudden you're like, but I never told you that. What's the lead term now? Here's what you do. You think, if I multiplied this thing out, if you did, we're not going to actually make you. You just have to think, if I multiplied it all the way out, can you see that it would have an x to the 3rd after everything got multiplied? If you can't see that, I'll show you why. Because this x would get squared eventually. Wouldn't that x get multiplied by another x and become x squared? Yeah. And then there's this other x here, and eventually that x squared would multiply by that x, and you'd have an x to the 3rd. Do you get how I got my lead term just by looking at it? My lead term is x to the 3rd. All right, here's another one. Y equals 2x minus 3, x plus 4, but it's squared. The lead term is what it's all about. In this case, what's the lead term? Don't say 2x. Don't say 2x squared. What is it? Say it. 2x cubed is correct. Now, one of the things that is true, it's kind of interesting to me anyway, is that only the lead term and the last number really matter. If this said like plus 2x squared plus another x, we don't care about the middle stuff. It's only the coasts that matter. People use that to rip on the Midwest sometimes. They call us flyover country because all the exciting stuff happens on the coasts. All right, so this is the end number, and we'll calculate that out tomorrow. I'll give you just a brief, for some of you, this is all you'd need. To get the last number at the end, it's called the y-intercept. To get the y-intercept, you set x equal to 0. So you'd put a 0 here, put a 0 here, and then you just multiply this all out, and that goes there. And that's how you get the y-intercept. We're not doing that today. That's just a preview. So all we really care about today is the lead term. Why? Because it tells you tons of stuff. I know that this polynomial is going up on the right. Do you know why I know that? Is it because of the x to the 3rd power? No. It's because this lead number is positive. Now I know some of you are thinking back to well, I know what this graph looks like. It's an x to the 3rd graph, so it kind of looks like this. And that's great. If you know that, cool. You know that the right end goes up. But I know it goes up just because the lead term's positive. If it's positive in front, it's like knowing the end of the story up front. I actually hate that in a book. If somebody tells me, yeah, the dog dies at the end, I'm like, don't tell me that. I don't want to know that. I want to be surprised by that. But we know this is a happy story because it's positive in front. It goes up on the right. It's got a happy ending. All right, so this one goes up on the right. How about on the left? Nothing directly says up or down on the left. Like this number here tells us the right end, period. This tells us if it'll be the same or different than that. Now, this end was up because why? Because that was positive. This is an odd number. Doesn't that feel to you like it should be different? The word odd and different are sometimes used to mean the same thing. Like you see a cat fully dressed in spandex walking down the street. You might be like, that's odd. And if your friend is like, oh, that's different, that's the same thing, isn't it? Odd and different kind of go together. So since that's odd, the ends go different directions. Do you get how this end's going up and that end is going down? There's only two ends to a function. There's the right end and the left end. And all we're going to do is teach you up and down. Later on, we might teach you a thing called a limit, which is something we usually use in pre-calc. But for right now, we're not talking about this in terms of a limit. We're just saying, is the right end up or down? All right, so here's a quick lesson on what I just did. Is the right end up or down? Don't overthink this. Is the right end up or down? Down. Is the left end up or down? Up. That's all you gotta be able to identify. We're not gonna be talking about rising or falling. That can be much more confusing. Because do you get on the left end, it's going up, yet on the left end, it's actually falling, because we read from left to right. Doesn't that kind of mess with your head? We don't have to do that though today. Today it's just up or down. So the right end is down. What does that mean about the equation? Do you get, I know that this equation could not be this for two reasons. That is impossible to be the right answer. Why? What does this 4 tell you? I like what you were thinking. You're thinking about 4 answers, and that's actually true, but that's not the point. What does the 4 tell me that means this graph can't be right? This can't be the right equation for that. Yes?
Tells you that the arrows are going the same way.
The arrows are going the same direction, and they aren't. So that could not be to the 4th. So now I'm going to erase that and say, what could it be like to the 3rd? Yes, because then the ends are going different directions. How about this negative in front? Does that match up with my graph? That tells you the end of the story. It's a sad ending. Doesn't this match up with that? Yeah. That is the correct. That negative in front tells me it's going down on the right. This odd number here tells me they have to be different. Now it could be right, except for one more thing. Does it appear to you that the y-intercept is actually 0? Look at the graph. Does it look like the y-intercept is actually 0? No. But yet this one, the y-intercept, which is where x equals 0, you stick in a 0 here and you'd find out y equals 0. So it isn't exactly right because it's not going through the point 0, 0. All right, here's another one. This one's up on both ends. You might be like, well, I know it's a parabola. Okay, well, then I'm going to change it because we're not doing much with just parabolas. We're doing things that have like weird little dipsy-doos in them. So could this possibly be that? No, it's wrong on multiple levels. Alex, can you tell me something that is definitely wrong with this? It's an odd number, and that means that the graph would have to be what if it was odd?
2 different directions.
2 different directions, good. Since this is the same direction, this must be an even number. Good. Is it right now, Mr. Patel? No, because why? That negative in front is telling you something. It would be telling you what? It tells you the end of the story. And that negative in front means that the graph should be going down on the right. Do you get this one could not be negative then? So now if I erase that negative, now could that be the right equation? Nope, because of one more thing. Think about the y-intercept. The y-intercept is where x is 0. You just stick a 0 here, and then you see what you get. Y equals 0. Is this one? Is my graph touching 0, 0? Then it can't be right. So this can't be the right equation yet. All right. Next level of this stuff gets much more complicated, but I don't want to try to teach you everything at once today. I think you'll get confused. So if I just give you this equation, you should be able to tell me, does it go up or down on the right? Is it going to be the same or the different on the other end? And what's the y-intercept? If you can do that, you should be able to sketch it. Like if I think it's up on the right, I think the y-intercept is 8, and then I think it's down on the left, then I could draw something like that. That is totally wrong. But try to figure out what is a sketch that could possibly be right. Just kind of sketch what you think it should be. You know the y-intercept, and you should know both ends. All right, this negative in this front screams it's got a sad ending. It's going down on the right. Raise your hand if yours was going down on the right. Good. This is the y-intercept. Because if I put in x is 0, do you get these will just cancel off? And y will equal 8. You get what I'm saying? So I know it has to go through 8. And then last but not least, the other end. Is it going up or down? Because it has to be different. Why does it have to be different? Because that power is odd. The degree is odd. And odd is synonymous with different. Okay, one more. You practice this enough, you're going to have it down before we even get into the notes. X minus 4 squared. X plus 3. First thing I'd like you to do is act like you're multiplying it out. But remember, all we really care about is this lead term, and it is not 3x to the 5th, but it's something like that. And then we don't care about all of this stuff. And then at the end, I can do it in my head, but I'm not sure you can. That's not really on today's lesson, but I showed you how you could do it. Figure out the lead term. Try to figure out the end term. If you can't handle it, it's okay. The kid next to you might be able to. I'll pause for a second and see if you've got this down so far. All right. It's certainly not 3x to the 5th. All you got to do is act like you were multiplying it out. What I mean by that is, if you actually had multiplied this out, do you get it to be x minus 4 times another x minus 4 times the x plus 3? And eventually, all these x's would meet up, and it would become x to the 3rd. Raise your hand if you had that right. Cool. Then, the other part at the end, if you caught it, I didn't even need to teach it today, but I thought I'd throw it in there for the kids that are extra good at math. Maybe you would like the challenge. That's called the y-intercept. You set x equal to 0, you put a 0 here, and this becomes positive 16 times 3, and 16 times 3 is 30, says 3 is 18, 48. And anybody actually have 48 without me saying, sweet, that's more than half the class. Okay, cool. Now, sketch it. Just make an XY. Not points. Like you could find a million points and you could find exactly where it is. That's graphing. I want to sketch. Okay, so here's a sketch. I know it goes through 48. Let's put a dot here and call it 48. I know it goes up on the right. You know how I know that? Because it's positive in the front. I know that this is odd, and that's different, and that means it's different on the other end. And then I can do whatever I want in between. As long as it goes this way, and goes through there. That makes sense to you guys? All right, so this is called higher algebra. In fact, it's called honors higher algebra. And so we could even ask you to figure out a stretch factor. Now, honestly, I think we took that out during COVID because it was one of those little things that was extra and we didn't need to do. But do you get that there could be a number in the front right here? Like it could be stretch with a factor of 2? But if we didn't know what the stretch factor was, we would just put a letter there. Do you remember what letter would go there? A. And then you'd have to like try to figure out, well, how do I figure out what A is? We would give you a point and we would say, by the way, this point here is at 5, 6. And then you could go put it in. X is 5 and Y is 6. And you could solve for the stretch factor. Again, just throwing in some stuff for the extra bright kids in case you wanted to know. But wait, you never mentioned a stretch factor, Mr. Server. How do we know the stretch factor? We'd have to give you a point, and you could stick it into the equation and solve for A, and you could figure out what the stretch factor was. Probably not even going to be in the unit. But I thought I'd throw it in because some of you guys are amazing at math. All right, so what is in the unit? Well, let's actually go do it. By now, this should be pretty easy. Polynomials or not? Is that a polynomial? Yep. Is that a polynomial? Nope. What's the thing you look for? Not weird powers or exponents. Yep. That's going to make you think. If you wrote that all on one line, do you get it would have a weird power because that technically is x to the negative second because it's on the bottom of a fraction? At a minimum, I hope you would have thought, that might be not a polynomial. It's not. How about this one? Is that a polynomial? How do you tell? Powers. Are the powers weird? Powers are not weird. This one is okay. It is a polynomial. In fact, would you please figure out the lead term of it? Because remember, the lead term tells us the end of the story and whether or not it is the same on both ends because of the degree. So if you can use the highlighted numbers here, you should be able to figure out that lead term. Keenan, what say you? And that makes? X to the fifth. I know it's hard, but I'm going to show you. Just wait. If you look at it like that, do you get, that's really XX times XXX? So it's X to the fifth. Okay? But wait, there's something missing. Who of you remembered that there was a negative? Raise your hand if you did. Cool. That matters. Okay, so then, why does that matter? Because then it's negative, so that tells me the end of the story. It's a sad ending. The doggy dies at the end. There's two movies I know of where that happens. Not going to tell you because I don't want to spoil it for you. Okay, so how about the other end? Fiona, what do you say? This 5, it's telling you something. It's going up. How come we knew it was going up? Because they'd be different. Odd and different go together. And then the only other thing is the y-intercept. Now, I don't think on the whole assignment today we'd ever ask you for the y-intercept. I'm just getting you ready because we're eventually going to make you do it. If you had to do the y-intercept, you'd put in a 0 for the x. The y-intercept is where x is 0. And this negative would still be there. This would be 5 squared is 25, and this would make it negative. Negative 25 times, negative, because there's 3 negatives, 27. And I have no idea what negative 25 times negative 27 is, but I do know it's positive because they're both negatives. So it'd be positive some huge number. So it'd have to go through something like that. So if I was going to make a sketch, I'd go something like that. But for today, we wouldn't require you to even know that. I'm just telling you ahead of time. The y-intercept is sec x is 0. All right, let's move on. The degree. Look at this one. What's the degree? Is it like a 5-star general? It's actually a 6-star general. This is a degree 6. Raise your hand if you knew that. Okay, good. It's just the biggest power. That's all. And you might be like, but I thought you were adding the powers. When it's factored like this, then you have to think like you're multiplying it all the way out. And it's different. Let's do the other ones first. What's the degree of that one? Be careful. Say it if you know it. Degree of this one. Say it if you know it. Degree 4. It's just the biggest power. Degree of this one. Degree 2. So what this was weird, why is that in the middle like that? Well, because they can. It's a math problem. It's not written as the final answer. You should actually rearrange it and put the negative x to the fourth first, and then plus x to the third, and then plus 7x, and then minus 2, and then they're all in order, in descending order. Biggest power first, you know, descending, lower, lower. But there's no x squared. It's okay. They don't have to have an, you know, like one of every kind of power. What's the lead term? That. What's the lead coefficient? That. -1. What's the degree? 4. Since it's an even degree, the ends have to go the same way, and they're both down because the right end is down, and that's saying they have to be the same, so they both ends are down. Down and down. And so far, I've taught you that that's the y-intercept. It's the thing at the end because fx equals 0. So then it would have to touch here. So that's all you'd have to know for today. Goes down on this side, needs to touch there, and also down on the other side. I couldn't even grade you for like what the wiggly part looks like. That's it. Both ends and the y-intercept. How about this one? What's its lead? Careful. What's its lead coefficient? If you were looking there, you were right. That's the lead coefficient because it's a 4-star general. It's bigger than the 2-star general, and this is like a private. Doesn't even have a x. It's called a constant. So it really should be written this way. But they can do this, and they will. There. Now, if that I've rewritten it, it becomes obvious that that's the lead term. This is the lead coefficient, and that's called the degree. I know it's going down on the right, goes through 10, and it's even, so it must be going the same way on the other end. So I could do whatever I want in here. It's going down, but I could make it go like boop-a-doo, ba-doop-a-doo. Eventually you'll learn how to do that in between part, but for right now, the only thing I can grade you with is down here, touches at 10. Let's move on. What's the leading coefficient? Oh, this is pretty easy. By now you know to look for this. This is the biggest power, and then what's the coefficient? It's the 1 in front of that. What's the lead coefficient here? Be careful. It's not 1. -1. What's the lead coefficient here? Say it if you know it. 5. How about here? Ew. -3. What's the lead term? X to the, be careful, 4th. Then there's a bunch of junk that doesn't matter. And then if I really needed this end number, I'd put in x was 0. And it'd be a pain in the butt. It'd be a huge answer. -15 times -27. Some positive huge number. Plus, I don't know, 812 or something. But then I'd know it was down on the right, same on both ends, so down on the left also, and goes through some big positive number. All right, on to the next slide. It's kind of light purple. I've taught you this enough that now you should just be able to do it. Liam, hint, it starts with a 2.
2x to the 6th.
Double check you. 5th. 2x to the 5th. That's called the lead what? Term. And the 2 is called the lead coefficient. What's the degree then? 5. All right. This is your final test. Do number 2. And let's say you think it's 4x to the 5th or something. Compare with the kid next to you and see if you know what the lead term is, and then circle the degree. If you know what the degree is, it's easy. That is not 4x to the 5th. How many of you caught the negative? Raise your hand if you did. Cool, that's the easiest thing to forget. because you're busy counting up the x's. 1, 2, 3, 4, 5, because that's actually worth 2. So that's like x squared to the third, to the fourth, to the fifth. There it is, negative x to the fifth.
Which will be to the 6?
What?
There's another x squared.
Oh, I missed a squared. Dang it. How many of you had 6 and better than the teacher? Okay, good job. I just oopsed. Okay, on to this page. All we'd ask you is it up or down? On the left. Up. Is it up or down? On the right. Up. If I had to make an equation, could this possibly be right? No. What for sure screws it up? The negative. If it's negative like that, it should be going down on the right. Now, could it maybe be right? Some of you are going to get me on a technicality because I told you how to find the y-intercept. You said put a 0 in here, and then it should be going through 0. If you put in x as 0, you get y as 0, and it's not going through 0, 0. So no, this still couldn't be right. But at least the degree of 4 makes sense. They're both going up. It's positive in the front. The right end's going up. So at least it had that going for it. All right, on to this one. All they're wanting to know is left side is this and right side is that. Left side, right side. And I'm fine with you even drawing arrows. The left end is up, for example. Now, on the Schoology quiz, you're going to have to type up because there's no... Oh, good question. On Schoology quizzes, they're always lowercase. Every single time. You won't use uppercase in Schoology quizzes unless they specifically tell you, which I've never seen. So, lowercase, up. So you'd write up. Here you'd write up. Here you'd write down. Here you'd write down. Because it's down. Over simple, isn't it? And I'm getting sick of this. It's too easy. So let's go to this page. They're trying to ask you to like discover this. I don't feel like this is worthy of trying to do discovery. So I already told you this. What makes this negative tells you that the right end is down. Negative tells you right end is down. There's not a negative, so the right end is up. There's a negative, so the right end is down. This one, there's no negative here, so the right end is up. But it's odd, so the other end must be going the opposite way. And here, right end is down. It's odd, so they must be going the opposite ways. All right, I don't like this chart. Skip it. Move on. If you like the chart, you can check it, and I can give you. You can come up and ask me about it. I'll tell you how to do it, but you're not going to be asked to make a chart like that. Describe the end behavior of this. You are definitely going to be asked to do that. So just make a quick sketch. Ethan, it's positive. That one in the very front, you know what the name for that is? The one?
Coefficient.
Yes. That lead coefficient is positive. What does that tell me? The right end is up. This negative here. That's important, Liam. Do you know what it does? Y-intercept is -6. And then the last thing we can check you on for today, we'll eventually get more complex, but is the other end. Could this possibly be right? No, because this says odd. Odd degree means they go opposite directions. That has to be going down then. Okay. Something like that. All I would check is up on the right, down on the left. Y-intercept's -6. And now you have a Schoology quiz. you've made it to the end. Would you please open up that Schoology quiz? And I would like to ask somebody, I'll use the dice so that you don't feel like I'm picking on you, to read me the first questions. Get there quickly, please. Be sure to watch the review video because you only get one chance at this, exclamation mark. Sometimes when I'm typing up here, I'm responding to student emails. That was a request on taking a retake. You guys know that if you just show up, you can just say, hey, Mr. Server, can I take that retake? You can do that. Except in your class, you don't have normal retakes. Your retake was the cumulative, which you took on either Monday or Tuesday of last week. I am in the process of grading them. And so it would kind of be an irrelevant question for somebody from your hour to ask about taking a retake. I'd be like, oh, you mean the cumulative? Because that's the retake. This was a kid from pre-calc. In pre-calc, we have regular retakes. If you bomb a test, you can retake it. Okay, so you've got it open, and let's see who the Dice of Destiny want me to ask. There they are. All right. Nikita, number 1, just read it to me.
State the degree and the leading coefficient of the following condition.
Ready?
F of x equals x to the third minus x squared minus 4x plus 3.
Excellent. Now, what was the 2 things I had to give you?
The degree.
Degree is 3.
Leading coefficient.
Leading coefficient is 1. Ah, that's pretty easy. Okay. Oh my gosh, it was close. I was looking at Afton, but actually, it's Lou. Number 2.
State the degree and leading coefficient of the following function. F of x equals 12 minus 3x to the 6th plus 4x to the 3rd.
Now, you don't have to rearrange it, but if you were gonna, do you get this 12 would go to the end? And that makes it easier to see that the lead is, well, there's the degree, and there's the lead coefficient. Make sense? I feel like this is overly easy, and that's good. Nice, easy day, first day back. Let me know if you get stuck, though. Sometimes kids get confused about, how do you know if it's up or down on the left? It's usually the left. The right side's so easy, it's just this number. The left side is whether or not it's even or odd. Tells you if it's the same or different. Odd is different. All right, and that's all I have for you for the video for today.